Now, what we really need to do is organize a IoT conference where all the people in the course have a chance to come together and meet up and present their findings and stuff. Don't think it'll work, but it'd be so cool because there's so many good projects.
That is true. That would be nice. Maybe do that if the next one turns out to be a bit smaller, just have a virtual conference.
Yeah, maybe I'll be able to do that.
Hard with 80 students, but two. Good morning, evening, after whatever it happens to be to everyone, and welcome to the 5th seminar in our series. Glad you could join us. So, what are we doing this week? This week, I'll have to do the normal reminder. Don't forget to do that. All meetings will be recorded, so we can post them to YouTube and people can review them if they miss them. This week we'll be running through what for the next couple of weeks, and in actual fact, there isn't a lot in the formal side anyway. This is working on your project, the prototyping, getting help from either us or your fellow students. We've got quite a few contacting us directly now, which we don't mind as long as we've got the time to do it. So we're more than happy to help out with whatever's going on. You should have had, or you should have submitted your market research costing plan already. We've received most of them, I believe. The results, thanks to Savash's work, will be available to you already. I think you can them direct through the feedback system, Savash.
Yes, so the ones that were submitted through WebEx, I finished them a little bit ago, 1 hour ago. So I have also posted comments there. They should help for students.
Thank you. David's requesting. See how that goes. So, where was I? Oh, yes, everything's submitted. You should have a result. If you haven't got a result, it's either not very far away or we are missing your submission. If you emailed it in, they might be a little bit results through. Savash has given feedback on all of these. If you want further details or clarification on a point, email the IoT capstone email and we will try to help you a bit more. So for the rest of the fortnight, we meet again. Watch the discussion boards. We'll be posting a few helpful little pieces up there, or we hope they'll be helpful. But there isn't any actual material to run through because, as I said, this is now the time to be finalising your prototypes over the next few weeks. So what we're going to do in these, sorry, I got a little bit more. Is it? It's probably to do with that annotate. Just to stop the annotation. I can't at the moment. The annotation was stopping me from moving to the next slide. Okay, so you should have all received your videos as well and the feedback on it either through email or directly on the YouTube video itself. I'll have to say it's been really, really impressive looking at these videos. Both Savash and I have looked at most of them and the others have done some as well. It's surprising how nicely they were produced. People have put an awful lot of effort into this. It puts some of our onshore project students to shame. Well, it's really, really good. If you haven't received any feedback, let us know so that we can actually some pointers. But as I said, generally really, really well done. Okay, so this fortnight, same thing as last, really, we want you to keep using your team as a sounding board and developing your IoT idea. Marks are actually through now, thanks to Savash's hard work. And a little pointer, I've created a Facebook page because we're coming towards the end of the course, and I thought it'd be nice if we had a common area to keep in touch. Let us know, or let each other know how we're going with the developments. Maybe get some help if you need it, but sort of meeting. So go to that shortened URL, fb.me/curtainio X. That was a bit of a mouthful. You can like that page and then get notified if people post things there. So hopefully it'll be of some use to you in the longer term. Okay, so for our chat this week, I'm going to talk about moving from the Savage Mode sticky taped prototype to something a little bit more professional and the tools that we should be using to do this. Next fortnight, David is going to talk about localization GIS using maps within your IoT solution. He'll be there for hopefully 3 of the seminars, and I'll run one of them as expert as he is on that particular area. It's a very interesting area, and using location-based server in IoT is one of the really nice features you can add. All right, but that will be next fortnight. So when we're heading towards production, we've prototype usually made from a whole bunch of off-the-shelf Arduino boards and sensors you bought from SparkFun or somebody else, and you've used that to do a proof of concept. You know that the idea that you have is going to work. You know where the problems are that you can iron out. You know you can collect data. You know how to manage that data and process the data, but it's not you would ever to sell. So we want to start looking at how we would develop something the next step on. And there's a few aspects we need to look at. The first one is the software development tools. And I'll go into these in a little bit more detail shortly. You'll all be familiar with, say, the Arduino IDE. It's very simple, easy to use, but there's other options out there. We need to be able to produce a custom PCB for many reasons. First one is you might want to have it a particular I'm using my microphone this time. Is it not good quality or?
No, I was responding to one of the students who was having issues with their audio.
Okay.
Yeah.
Microphone.
And
so there's a lot of reasons you want to produce your own PCB. The first one is you might want it in a particular shape to fit you're developing. You want to reduce it to the bare minimum to reduce costs. So you would look at producing, rather than an Arduino, a certain amount of memory. You may not be using all that memory, so you create a version of it, less memory. Significant cost saving to the device itself. If we have a look at things like Raspberry Pis and Arduinos, they've got lots and lots of ports on them you may not actually need. And each one of those ports, even though the component is only worth a few cents, the manufacturing cost of putting those ports on is actually quite high. It takes up more space. The additional interface circuitry that you use draws more power, lessen your battery life. And for a true production device, you would want to create something that has exactly what you need and nothing extra, unless you're planning to use it later. Said that is to reduce the cost, number one, the size quite often, but not always, and power consumption. So you would want to look at, and there are lots and lots of various levels out there, and we'll have a look at 3 that help you develop the PCB. One things. The case you put your device in is critically important in many cases. If we look at devices, my phone's disappeared, but the reason Apple iPhones sell so well is they're really, really pretty. The reason iMacs sell well is they're really pretty. The reason Dell products don't sell well in the consumer markets is because they're pretty ugly. I've got it back, but I don't really need it. So the package you use to house your device is critically important on the market penetration you're going to get, how well people will think of your product. People don't like cheap, tacky boxes, even if they work really well. They want something that's nice, looks good, solid. Housing is one of the key features that you should look at, and we'll have a look at a few different production methods there and where we would use them. I'll get to that. Okay, so starting at the software level, we should all be reasonably familiar with the Arduino IDE. We've used it in, obviously using it with our development of the prototype. And It is useful and it's great for quick prototyping. So you can hack out some code really quickly, really easily using the Arduino IDE. However, because it's got lots of built-in libraries, it's not actually that efficient. So when you use a particular function call within the Arduino libraries, they're not necessarily optimized. And they're not optimized for several reasons. Number one, it's done by open source, so it may not be the best programmer that's doing it. But additionally, it is cross-platform. So it means that you can use the same IDE for a few different processors. And each processor uses a different set of machine language instructions. Basically, that tell the computer what to do. So because it has to be on a wide range of platforms, they don't have the resources to make each of those implementations efficient. So they are really slow, etc. So when you're using the IDE, the Arduino IDE, it's not necessarily the most efficient way of developing software, but it is free, it is open source, so you don't have to pay any license fees, which is critically important if you're doing fairly large runs. You don't have to pay for every installation that you produce. So it has advantages, but mostly in the early prototyping stages. Okay, so what else is out there? And the one I'm using as an example is a particularly good one. Vash will love this. It's Code Composer Studio from Texas Instruments. This is a full-blown development environment for the software. It's not simple to use, but it is designed specifically for the Texas Instruments range of products, which means it's optimized for that particular set of platforms. It has the ability to do an awful lot in development itself, particularly to do with efficiencies. If we look at this blue circle highlighting some assembly language, which is close to the language the machine speaks, we can examine it directly within the code itself. We can add machine language in, which is much more efficient. It's working at the level of the CPU, so it can be made very efficient. It has things like hot looking where your code is spending most of its time, so that you can build efficiencies into those particular areas, and interacts with the hardware very, very well. So if we look at this block here, we can see that we've got the hardware layout, at block level, but the hardware layout of that particular platform. Now, the IoT6 module, we talked about JTAG. And JTAG, we talked about for the security issues, being able to break into devices using this JTAG port. It's actually designed so that you can do automated testing on your... Go back. Using earlier with Arduino, there is no way to get access, I shouldn't say that, there is no easy way to get access to the JTAG port on a particular board. However, with this particular development environment, we can write diagnostics to test boards as we're manufacturing them. Another step on from what we can do. We can build very large projects. It's got a pre-structure there. We can deal directly with the type of I/O that's available. Sebastian, you've got anything to add on Code Composer? You're probably the greatest user of it in the group.
Just to add to that, adding kind of assembly into C bits of the code, especially gets useful when you're dealing with, say, dealing with interrupts and dealing with turning on low power modes, because you're directly dealing with when your memories and registers are going to be updated. There's really no easy way to kind of see the contents of your register and memory blocks being updated using Arduino's IDE and with something like Code Composer, or there's also another one, IAR. That one's by Texas Instruments as well, but that one's paid, more of a paid subscription. But there is a size limited version you can use, and that one I think can make programs up to 8 kilobytes, so it's not too bad. And the idea is, because if you say you're writing to a register, you can watch the content of that register being updated in real time. And you can step through the code line by line with breakpoints there, and that really helps well, especially when you're starting to debug your code. Whereas with Arduino, because you're using lots of these built-in libraries. Only your code is not as optimized, the actual size of the code increase because it has to import all of those libraries within your micro as well.
Yeah, Sebastian's raised two really good points there. Debug is a major one when you're trying to make reliable software. The Arduino IDE is not particularly good at debugging. Some of the other open source debugging are just terrible to use. I'm sure Hannes would talk about those, knowing that how difficult they can to use. And the issue of anything that requires immediate action, you use interrupts. These are a signal that's sent to the CPU that says, stop what you're doing, pay attention to me now, and take care of the issue that's just come up. So it interrupts the normal. You service that interrupt, do what it needs to do, and then you return back to the normal program. That is extremely inefficient to do in high-level IDEs like the IDE. But in something like our Code Composer Studio, it can be handled at the hardware level. So again, very efficient. The downside to this is IAR and Code Composer Studio at commercial levels are very, very, very expensive. Last time I bought the Composer debugging system, it was $6,000 US for a single license. So it really is only for the production environment. Okay, so software, there's lots of things in between this as well. You can use GCC, which can compile to many different languages if you're running on a Linux platform, but there's quite a few around, and this is just basically two ends of the scale. Free, easy, simple, and full-blown commercial development environment. So we need to look at how we're going to use to develop our software. We need to also look at the tools we are going to use to develop hardware. So I'm going to blame Savash for this one, but it wasn't him that did it. A sticky tape prototype on the left, and it's a great way of getting the proof of concept. You can see that we've got a off-the-shelf radio transmitter. We won't tell if it's Bluetooth, but whatever the radio is. We've got an inertial measurement unit here sitting under right there. We have a battery, switches and plugs, sort of just tacked on and held in place any way we can. And then we've got these cables, which are a big problem, keep breaking. But it works as far as testing out the idea. This is really, really cheap. Make one up, decide that it didn't work for what you want, so you just create another one with the modifications. I'll go into the housings a bit later on, but this is just a 3D printed case to hold it. As you can see, it's a little bit, but it served the purpose. When we get to the point where we're looking at actually producing something that we will supply to users, we don't want it, number one, looking like this, because if anyone sees inside, they're going to be... and we need the reliability, which we don't get when we're running wires like this all over the place. There's also lots of things on here that we don't actually need, so they're costing us money, basically. Like this little header here, it's only worth a few cents to buy the header itself, but it's actually expensive to put it on the board. So that would add production run probably $1 or $2 to the cost of the production. Again, it's the same with these switches and things. But we've got a couple that we've made some time ago. They're not actually IoT devices, these two. It's just a photo I had. This is a text-to-speech engine for turning output into voice, English, Spanish, German, Farsi, and a few other languages. Manufactured these PCBs ourselves to minimize the overall cost, so we could actually do a production run of them and make it fit the packaging that we designed correctly. This one here is just an ultrasonic guide for a blind. Vibrates dependent on the distance you are away from the item, the ultrasound sensor down here. And it's still sticky taped, but that's just because the battery came loose. But it's actually a production model, that particular one. So we can see the difference between this and this. Because we don't have wires hanging everywhere, nothing's loose, aren't just stuck together. They're number one, smaller, they're cheaper, and they're more reliable. So this is why we want to start looking at making PCBs. So how do we make PCBs, you might ask? Hopefully someone is asking. Let's have a look at a couple of ways we can do that. Now, again, there's a whole range of packages you can use to design your PCBs. This is one that's very useful because it's free. It's extremely easy to use. It's not a simulator like Tinkercad. It does allow you to enter code and upload code to a physical Arduino, so you can test it that way. But it does do all the PCB layout, etc. It has a large range of components that we can use. There. And I shall open up my fritzing. Bear with a second. Right, I'll have to open a new one. I must have closed it. There we go. Okay, so here's a fritzing just from their library, and we have the ability to lay things out in the same manner as we would with Tinkercad. So this is nice and visual. We can see where things go. We can move them usually. Oh dear. Spinning wheel of death. There we go. And I'll undo that. So we could move things out the way if we wanted to. We can change the order of the LEDs, etc. The important part of this is, or the fun part is, it will actually produce the schematic diagram. This is the electronics version of our nice graphical interface, and this is what the engineers would like. We can see that we've got our temperature sensor connected to our Arduino Uno, the pin that we need, there. And here's our diodes on the digital out pins here. So the schematic allows us to see the logic behind the circuit, the actual circuit diagram. And interestingly, if we go to PCB, it lays out a PCB for us. We've defined, and we can edit this. So if we didn't like the temperature sensor there, we can move it off over to here, for example. So we'll move it to there, and then we can reroute it. Use an auto route to do that. And it doesn't work. That's the trouble with auto routing. Quite often doesn't work. We've got cross tracks here. PCB from here. We'll bring it back. Oops. Bring that back over here. So where was he? There we go. We'll put him over there where he belongs. And when we, before we do that, we can actually test this out on a real Arduino by going to the code, and we can type our code in and actually have it run on a real Arduino using our breadboard here, make sure everything works, and go to PCB, go to Fabricate, and it takes us to their sponsor that will allow us to a PCB. And in this case, they're expensive. It's loaded it all up. We can change a few little bits and pieces on it if we'd like. Buying 3 of these boards will cost us €26. So that's kind of expensive, but very, very simple and easy. So things like fritzing are great. They're free. They're capable of doing some reasonable development on. There's usually a board size limit. There'll be a number of layers that you can do on it. In this case, I think it can only handle 2. I'm not quite sure. Oops. Sorry, wrong buttons. I think it only handles 2 layers, but I'm not 100% certain on that. So fritzing, really good one, free and easy to use. In the middle, we've got something like Eagle. Now that comes from the same people as Tinkercad, and it's a little bit more advanced. You can get a free copy. So if you want to start getting, oh yes, you can tutorials online. You can get a free copy, which is limited in its capability, 2 layers only, fairly small board area, but you can have a look at the features. With this particular one, it's because you can learn it on the free version, and as you require more features, you're starting to do more complex designs, you can just upgrade so it has more capability. You have to relearn another package. It's also cross-platform, which is very nice as well. You can run on Linux and Mac and Windows, etc. That's sort of middle of the road, just has more capabilities if you're willing to pay for them. If we head to the top level, this is just one example of the top level design packages. There's OrCAD and this one's Altium. It's designed by a company in Tasmania, Australia, and it is a full-blown design system, a full CAD system for PCBs. Not only will it do the normal layout, you don't have any limitation on the size of the boards and number of components. It does lots of fancy little tricks. For example, you can look where the power consumption is and it will give you a heat map of where the hotspots are, so you can look at cooling. You can do some signal analysis on it. It does testing, much better auto than the first one. Must be getting late at night. Fritzing. And it will also do a 3D drawing of the board itself, so you can look, is it going to fit in the case? Do you have to make any physical modifications to it to be the design that you want? So very, very powerful, very, very, very complex to use. And they usually for 5-day training courses just to get you started. So you can imagine the complexity involved in it. And as I said, it's expensive, around about $25,000 per license. So for commercial use, it's not something you'd be looking at commonly. Okay, so we need to design a PCB. We've got lots of tools out there, lots of tutorials online, and there is a range of design packages depending on your financial situation, how important the tolerances on the design are. If you're doing very high frequency PCBs, then you would need to have a better package than, say, Fritzing. Okay, so that's how we would design a PCB. Have a download, have a look at them. They are a bit of fun to do and quite cheap to produce the PCBs. Now I'll just quit out of here again and we'll go back to that one. Where are we? This one. If you want to produce PCBs at a reasonable cost, you export the PCB design out of one of the packages that you're using. They all do this, I believe. And that produces something called a Gerber file. A Gerber file is just a format for PCBs. It comes from the old Gerber machine, which was an early PCB vinyl cutting machine. I won't go into it. Look if you're interested. But it's a particular format for laying out tracks. This particular company, All PCB, was one I used very recently for Sebastian's favourite project, the solar car. And we got, I think it was 9 printed circuit boards made. They're fairly small. They're about 3 inches, 75 mil by a ½ inch or 12 mil. And we got, I think 9 would fit on the sheet of material for 99 US cents. That was great, except to get them over here in time, we had to use DHL and the shipping was $25. But even so, 99 cents for 9 of these boards, it was ridiculously cheap. If we weren't in a hurry and could wait a couple of weeks for it, it would have been $1 or $2. You can get PCBs made very, very quickly, very cheaply, with only one minor drawback. The Chinese makers who do have issues with quality control, you've got to be very careful when you get your back. And if we look at the this particular device, this double talk PCB, we got, I think it was about 200 of them made, and they populated them as well. So you can actually get them, put all the components on for you. And they turned out to be, I think from memory, around about $10, $15 each. So very, very cheap to get made. The problem was around 25% of them didn't actually work. But given the very, very low cost, it's not good for the environment, but given the very, very low cost, it's better to get that done financially than at one of our local manufacturers who would have charged us several $1,000s for that particular run, just for the setup, in fact. So manufacturers do have a, just be aware their quality control, oh, I did have it there, has a, you have to be very careful with the quality control. Okay. So the last bit I wanted to cover was the housings, and this is something that should never be neglected because it is what your customer will see, and it tends to point towards what people perceive the quality to be. A few ways that we can do this. The first way that I mention is Jiffy boxes. It's these square boxes down here. They come in a variety of shapes and sizes, and they're an off-the-shelf item. They're awfully ugly, but they do work. And you can get them weatherproof as well, and they hold the PCBs nicely. Got got very, very low runs of a device that can go out of sight, for example. So something out in the garden or in the field, looking at agriculture or hidden inside a car. These sort of devices or these sort of housings are quite adequate for that use, and they are in small numbers. The other way you can do it is 3D printing, and I've mentioned 3D printing before, and I've used this particular example on purpose because it shows the downside, one of the downsides of 3D printing. Quite often, particularly if you're trying to produce things fairly quickly, the quality suffers. And this one we can see each of the layers that appear as the material is laid down. We've got a textured top, not because we want, because that's the bed it was printed on and the pattern from that bed. But the nice thing about these is they are very, very cheap. You can get a kilo of plastic for a 3D printer for somewhere between $20 and $40, and that's an awful lot of cases you can build with a kilo of plastic. It's very, very slow to produce. A box like that would probably, on a filament type 3D printer, would take 2 or 3 hours, would you say, Sebastian? To actually produce?
Yes, probably. Maybe slightly more as well, but yeah, 3-4 hours.
So not quick. And every now and again they'll warp, and we can see a little bit of warping in this one where the edges are lifted there and the gap's greater here than it is down there. They won't always correctly anyway. A fair bit of loss, or some loss in that. But for very small runs, where the time it takes to print each case is not an issue, so you can have a whole array of 3D printers knocking these things out, and people do. They can actually form a very good purpose, and they're very good for a manufacturing prototype. Something a manufacturing prototypes in a sec. Another way of doing things is our vacuum casting. This is done on plastics with vacuum forming. A good way of, again, fairly low runs, mid-range quality, and relatively cheap. You've got to make up a mold to produce them, but the mold is not terribly expensive. Heats the plastic, pulls it down over the mold, and then uses a vacuum to draw it into all the cavities. Then you just drill the holes and other things that you need. So good for medium runs, medium quality, so not bad for that sort of application. At the top of the line, as far as expense and numbers goes, is injection molding. Injection molding is where we have a mold, as the name suggests. I'm just using a little test piece. It's held together and you squirt it full of liquid plastic, normally just heated plastic. Forms a device, you open the mold up and out pops your finished product. The problem with this is not the cost of each of these. The cost itself per item is incredibly low. It can be like one of these Jiffy boxes, 1 or 2 cents, even less if you're doing large. The cost is in this manufacturing these. I used to have a company that made these, by the way. It was part of developed to machine these things up. So we used to make these guys, and generally they would cost somewhere in the vicinity of $10,000 to $40,000 to make. So you've got a very, very large investment initially to get your very cheap items out. So you need very large product runs. The other issue with this is if we want to make a change to the design in our 3D printed, we just change the pattern in software and set the printers off again, and we've got a new design. Yeah? You take your $40,000 investment, you throw it in the bin, and you spend another $40,000. So making change at this point is extremely difficult and extremely expensive. But the quality can be very, very high. You've got a huge range of materials you can make things out of. You've got all these different colors that you can use. But it does have that very high setup cost. Okay, so that was all I wanted to cover tonight. But the next, the last 2 weeks of the course, we don't run anything, but we'll probably still run these seminars just to make sure everyone's happy and have got what they want from the course. But it's there so that we can actually finalise your marks. So we will finish in week 12. All right, that's our little talk for tonight. Have we got questions from people specifically, or does anyone want to tell us how they're going with their project?
So yeah, if you have any questions, just feel free to use the ask a question button, that raise hand next to your name. I'll unmute. So yes, Sana has a very quick to your question, Sana. While Ian was talking, I put a bunch of links on the discussion channel. Two websites that offer 3D printing services and links to code are, if you're interested in kind of following up on what Ian discussed. So I'm gonna go and unmute Sana. Yes, Sana, you're unmuted. Go ahead with your question.
Hello.
Hi.
Hello. I don't have any question, but I to show you where I reach with my prototype, and I just want to tell you what I do with my prototype. I just need to open my camera. Okay. Okay. This is the.
Don't think we have your camera.
What about now?
Okay, I'll.
What about now?
Just 1 second. Let me just make you. No. All right. Okay, she's presenter now. Yes. Okay.
Okay. I just want to show you first. I start. Bluetooth. This is the Bluetooth, but I found some problem. I asked question and sent email, but I got no answer. Maybe you could find my question. I have a problem with the Bluetooth, low energy. I don't know what's the problem. So I switch to another transmitter receiver way. So I start with this HC12, and it's work very fine. And also I one which is NRF. For this is the receiver, and this is the transmitter. It's also work very fine, and I can send the data from my IMU sensor from my sensor to the laptop. And it's serial of IDE. It's work very fine. And I also have one question about IMU data. It seems the data is not correctly read. I don't know. Maybe I don't know how to do the calibration. If you can help me with that. That's all.
Yeah. Can you tell me what IMU sensor you're using? Was it MPU 9250?
This is the sensor I use. It's number 9255.
9255. Okay, so that's probably the newest generation of that. So are you getting? So what's the problem? Are the readings you're getting off the sensor?
Yes, I read
Don't
the
make
yaw
sense,
and pitch
or
and roll. It doesn't make sense. When I read, I understand when the sensor is not moving or it's unstable. It should be zero, the roll and pitch. But it's get some bars.
So but keep in mind, even like with IMU sensors, if you have them stationary, because say the accelerometer is working with gravity, you'll still gonna get some readings in the direction, even if it's just stationary. That's why you need calibrations. So, for example, for my own project, that's the main problem that I'm trying to solve. Like for to finding the initial hand position. At the moment, I have the children just place their hands on a table for a couple of minutes, so like for a minute or two, and then reading that I get at that point, even though it's not zero, I'll count that as zero, and then whatever reading I do on in any of their movements, I get a difference. That's one of the main problems to solve. So how do you get that position? How do you find out when you have the sensor stationary, what would be your zero and ground level. Now, in your case, because it's head movement, you could, again, that's going to be the challenge. So I would start by, say, sensor to a head and see what would be the normal way that your kid is resting his head, and take that as your initial position, and then any movement that you do in addition to that, the difference between that can be that could be the start. It's not a very good way of doing it. It's kind of a workaround of solving that problem. Anything you wanted to add, Iain? Maybe your solution?
Okay, thank you. I understand. Maybe I have some calibration more about this, and if I face any problem, I'll try to send an email for you.
And one more suggestion as well, because then it's as Iain said, having wires and things like that, and especially adding the wireless communication can add noise to your the problem you're currently having. So what I would recommend is to narrow down your problem to just fixing the IMU bit. You can just connect the IMU to your Arduino and then read this data through your serial monitor and do your orientation tables there. Once you get that to work, then you can kind of move forward to, okay, now I'm going to transmission to using the Bluetooth modules or your RF transmitter to your receiver. So that helps isolate down the problem, especially when you're dealing with this prototyping level and you're using lots of jumper cables that can cause lots of noise and from experience, it's going to be difficult to narrow down a problem. Then you suddenly realize after an hour, oh, it was just wire that was loose somewhere or like producing weird noise to your system.
Okay, thank you. Finally, I just want your advice about which transmitter receiver. Should I use C12 or 24?
Well, as Iain said, we've had good luck with RF12, but if you do want to eventually make it make a phone app to communicate with it, it would be probably better to kind of get the Bluetooth module working, but then you can just kind of if that work later on the phone app, and instead of capturing the data using Bluetooth, you would capture that data using that you would capture using your phone app. So you would have already worked on part of it. You would have already worked on the communication part. Yeah.
Thank you.
We have a question coming from James, asking whether there's any preference with IMUs who are producing raw data, like a change in voltage, compared to the ones that give you acceleration and angular velocity right off the bat. And I'd say probably the one that gives you the raw data, because with those ones, with the ones that like that ambient lamp one that I used the other day to show the example, we don't know what sort of algorithm they're using to get their orientation. So, especially if you're doing any processing later on it, it would be probably better to go with something that doesn't do that. So that's where that's what I would say. Iain, I think you're muted. Okay. Yeah. Yeah. And I'd say, speaking of references, because going through the market research report, there were, I'd say, not many, about 10 who didn't have references. So be careful about that. Especially since a couple of people want to use these sort of as a stand-off point for getting into like kind of converting this to a paper. You definitely need to have references and. So we have probably our final question coming in, but here he's asking about Bluetooth 5, use of Bluetooth 5 or any information we can